Viewers like you make this program possible. Support your local PBS station.
One of the main reasons we wake up every morning. Another beautiful day in paradise, but let's go!
This tower may be the most complex and costly building ever constructed on American soil. It will be a place where people will come to work and to remember.
We all saw a lot of things that, we weren't meant to see, should never have to see.
Out of the shadows cast in this city's darkest hour.
We lost much on September 11th. We lost 3,000 people. We lost our offices. We lost Lower Manhattan.
It will rise a symbolic 1,776 feet. Now, the race is on to get it finished.
It was a national imperative from the president on down to rebuild. Whatever was built needed to be the safest building in the world anywhere, period.
This is the inside story of the final push to build the tallest skyscraper in the Western Hemisphere. The toughest skyscraper anywhere. This is One World Trade Center, and it is a super skyscraper. On September 11th, 2001, two hijacked planes brought down the Twin Towers of New York's World Trade Center.
On 9/11, I was assigned to a project in Midtown, 745 7th Avenue. I saw the towers on fire. I actually saw the towers fall from where I was in Midtown. It was an extremely disheartening experience.
We were all down here within hours after it happened. We all saw a lot of things that, we weren't meant to see. Different people didn't know whose family was lost yet. Neighbors, friends, family. The cleanup was tough.
That night, less than 12 hours after the attacks, the mayor of New York addressed his city.
We're going to rebuild. We're not only going to rebuild, we're going to come out of this stronger than we were before.
Before the debris was even cleared, the debate began. What should the new structure be? A global competition produced some wild ideas. But then a real plan evolved. Unveiled to the public in June 2005, the final design is the vision of architect David Childs.
The building is actually a very simple shape. So you just take this single shaft of crystal, square in its nature, and just slice away those corners slightly. That's the building.
2.6 million square feet of floor space, 104 stories, smooth glass walls hiding 50,000 tons of steel, and 180,000 cubic yards of concrete. A 408-foot steel spire will take its total height to 1,776 feet. But most importantly, it will be built to survive anything. Explosions, any storm, even earthquakes. There's never been a tougher skyscraper, or a skyscraper that's been tougher to build. Work began in 2006. After the foundations were laid, the ironworkers moved in, connecting a forest of beams. Behind them came the concrete crews, pouring the floors and the central core, which will be the building's strength. Then thousands of other workers, each with their own expertise. The higher they've climbed, the harder the jobs become.
All this is happening around us. 3,500 people at the site each and every day, just construction workers.
As director of construction, Steve Plate oversees them all.
Monday. You're ahead of schedule, right? You're always ahead of schedule. Good man, Brian.
You look at who passes through the gate, it could be 8,000 to 10,000 people. In addition to that, we have 26,000 people employed by this project.
Every one of those people has their own 9/11 story. Steve Plates is that but for an accident of fate, he would have died that day.
On 9/11, my son, who rarely, if ever, asked me for a ride to school, decided to ask me for a ride to school. He said, "Dad, you have time for everybody else. Can't you make some time for me?" So I said, "Yes, let's go." And we drove him, and I missed my train and arrived here right after the plane had hit, which my office was located on the 82nd floor, and I'm usually at my desk by about 7:45. So circumstances are such that I feel very personally attached to this project because the people I used to ride the elevator or ride the train with are no longer with us. So.
In the years since he started to drive this project, Plate has allowed himself just 3 hours of sleep a night. August 30th, 2012, 6 years into construction. One World Trade Center is just past the height of the original Twin Towers, and construction is entering its most difficult phase. There are 400 feet still to climb, and just 40 weeks to do it in. Up top, the crane drivers make the platform that will soon hold the spire. Down below, the men who fit the curtain wall, the building's glass skin, are getting ready. They are about to go to work on floor 84, 1,100 feet above the street.
So just a way that our shop drawings are broken down, we go to a plan. It gives basic layout of the floor, it gives our part numbers, and then it calls out details of specific components that we have to install. Yeah.
Ryan Kernan spends his days solving what may be the world's most complex jigsaw puzzle.
Questions, I gotta have an answer. That's why they call me the professor, yeah.
The finished building will be covered in 1 million square feet of glass. That's 7,000 tons. In 14,000 panels. Each is different. Each is numbered. Each has a designated position.
I'm an architect by education. So it takes, a guy like me that understands the design and what we need to do, and then the guys with their hands on the bolts, hands on the cables, make sure everything is done right.
Another beautiful day in paradise. Let's go. Let's get this going. Showtime.
These are the men who turn plans into reality. They've worked their way up from ground level, one floor at a time, around 15 panels a day. And the man in charge of the 12-man crew is General Foreman Frank Coletta.
Looks good, right? How are all the joints? You like the joints? These panels need to be within a 1/16 of an inch. So this envelope, regardless of where the structure goes on the inside or the bones of this building, this envelope has to be straight and smooth. So when you look up this building, you'll notice it in the sun if we missed anything. We always work together. Everybody looks out for each other. So that's why I love coming to work in the morning. If I didn't have guys like this working for me, you know how hard my job would be? They make it look easy.
But it isn't easy. The operation they're about to perform requires both expertise and nerve. And even though they've done it thousands of times, nothing is routine.
Move that garbage can, Johnny. Give him some room. Those leads are gonna get those leads out.
They're going to launch a 13.5-foot window panel out into space, 1,100 feet above the city.
Let's do it, baby. Showtime coming up. Let's go.
Each panel is made from 2 pieces of blast-proof glass, of a kind normally found in military installations.
One panel at a time, baby.
It's stiffened by thick steel bars. That means it weighs almost half a ton. To line up, it has to be lowered with complete precision. But this high, the team faces 2 problems. The first is that, like any tall building, One World Trade Center sways.
Basically, when we're setting panels, you're looking through a transit to be able to set the panel. You're trying to shoot on a mark, and when you line up your crosshairs on the mark, the crosshairs really roll around the mark. The top of the building, you could get anywhere from, maybe 6 inches to a foot, and that's just due to the building moving.
Super tall buildings are very much like the mast on a sailing ship. They're anchored at the bottom, they're very tall, and the greatest force is not the gravity, it's the overturning moment, the wind pressing against the top.
The second, bigger challenge is that high wind poses an immediate danger. If it catches a corner, it can flip one of these panels and send it swinging uncontrollably. Though the crew's harnesses keep them from falling any distance, they can still be hit or thrown against the side of the building.
The wind is our biggest enemy. As we move up the building, it gets exponentially harder. We can deal with the rain, we can deal with the heat, we can deal with the snow, but the wind, that'll shut us down.
Today, they're hoping to hit that 15-panel quota. But if the wind gets over 30 miles per hour, they will have to stop.
We're pretty close to the limit of hanging capability due to the wind. The wind today is probably around 20, 25 miles an hour.
But even at 20 or 17 miles an hour, if the wind is too strong and my guys feel that it can't be done, then it's not done that day.
Humbling experience right here, baby.
The fact is, of all the threats that face this tower, wind is by far the greatest. So much so that it helped dictate the building's unique shape. The winds that flow around a true skyscraper, that's a building more than 400 feet tall, will regularly get close to 100 miles per hour. Enough to rip the glass out of a conventional building. That's why the older skyscrapers are fortified with steel and stone and small windows. But the problem rapidly intensifies as the building gets taller. Forming at its corners and along its sides, columns of air called vortices create a powerful sucking force. They pull the building around, and under certain conditions, they can make it shake violently. The architects of One World Trade Center knew they had to combat this, but they weren't about to give up their walls of glass.
We would have one piece of glass vertically from the ceiling of the office that you're in to the ceiling of the one below you. That means that you completely have only glass and only one joint on the outside.
The solution they chose is what experts call confusing the wind. They gave the building a shape which constantly changes as it rises. At every level, it deflects the air in a different way, and the vortices can't gain strength.
So it's basically a square on the bottom and a square on the top that's rotated, and then the vectors and lines are drawn in between them. It reduces the negative pressure in the vortex on those corners, which is, an ingenious way to design a building this tall.
The architect's vision remained intact.
It's like one piece cut out of a piece of ice. So you read that as a single, simple, dignified object.
And Frank Coletta's team got the biggest job in the business.
It's a different job than all the others. Of course, it's big. It's the biggest job. It's the biggest curtain wall job in the Western Hemisphere. Nobody set panels this high in New York City. So we're breaking new ground here.
Don't tell me that easy, Will!
Having completed a row of panels, they now face the most difficult phase of the operation.
When you get to the northwest corner of the building, the wind gets pretty high, and it takes a lot for the guys to hold on to the panel to be able to set it into place.
Be right with the corner, Michael? with the wind and everything? You feel good with the wind and everything? You're nice?
Yeah, absolutely.
Good.
We're good, we're good.
All right, nice and easy.
Corner panels are a tough panel to hang. You know, when you're on the corner of the building, the wind can get intense and it has a tendency to take that panel like a sail.
Let's go hooks down. Let's see what we got. Careful with the wind. You got one shot, make it a good one. If the wind's coming across the face of the panel, then it can pull it out of your hands. They're actually a little more delicate than the glass panel. They can dent, they can wrinkle. They weigh more. It's basically a 1,200-pound egg. You got to be careful how you handle it. Tough panel to hang. The wind's got to make 3 spikes on the way down while you're marrying it, while you're pulling it over, while the wind's blowing.
Hold on. Let's go, Father.
There you go. Nice.
There you go. Where's that? Showtime.
If all the glass that they've fitted so far were laid end to end,
Coming up, coming up.
it would stretch more than 30 miles. Over the coming winter, they must race to finish the top 20 levels, each more challenging than the last. But every level they seal, the building gets stronger. And on One World Trade Center, strength is everything. "18 stories above the glass fitters, Brian Walton is waiting with his concrete crew.
How you doing, Danny? Everything good?
They have poured every wall and every floor in this building. The higher they go, the harder it becomes. But as they get ready to complete floor 102, they're nearing the end of their part in the build.
So you started out down 65 feet below street level, and I've been on the job every day since, so I'm really looking forward to hitting the roof here in the next month or so. The higher we get, seems to be a different challenge every floor.
They're not slowing down yet.
We actually started the slab we're standing on last night at midnight. It was about a 400-yard pour.
That's 600 tons, and all of it had to be pumped up from street level.
Working at this elevation, basically no one's been pumping this high, especially with these mixes we're using, these high-strength mixes.
Brian knows that even at this stage, any delay will have a domino effect.
We have to keep pace to keep all the other trades moving behind us. If we start to slow down, it only slows down the trades below us, and it's a snowball effect from there.
The fitters can't come in until the walls and floors are ready. But the concrete he needs is on the other side of the river, in Red Hook, Brooklyn, where a team of drivers is getting ready to set out. The fact that they've done this hundreds of times before doesn't stop it from being a high-pressure operation. The recipe which makes their concrete super strength, blast-proof, and quake-proof also makes it very quick drying. They have just 90 minutes to get it on site, offloaded, and pumped up to where Brian's team waits. Every week since they began this job, the building's risen 1 floor, and the concrete has had to travel further. But the 90-minute deadline hasn't changed.
If you exceed 90 minutes, it starts to tighten up on you, and that will cause a weakening of the strength of the concrete. The load is out of conformance, it's no good, it can't be used.
To date, enough concrete has been poured at One World Trade Center to make 2 Empire State Buildings. By the time the job is finished, the total will be in excess of 150,000 yards.
It's a continual process. As we load each truck, it comes down, the belt starts, he loads the hopper, and it's basically a round robin. It's just a continuous process that goes on and on all day.
Sometimes the build demands up to 15 trucks an hour. And even after it's delivered and poured, there is still the chance that it has to be ripped out again. No building project on Earth has tougher quality control. This testing facility analyzes samples from every load of concrete.
Consistency is key. You can't afford to have a bad load of concrete going in there. We want what we ask for. We will not settle for anything less, not for the World Trade Center.
The samples are left to cure and then placed in this chamber. They're then subjected to unimaginable hydraulic pressure, measured in pounds per square inch.
Your typical concrete is about 4,000 PSI, okay? That's your typical concrete for your foundations that are used for homes, for sidewalks. Here, the strength for the core average 16,000. So it can carry a lot of load.
16,000 PSI is 8 times what you get in a car crusher. It's the pressure you'd find at the bottom of the deepest ocean.
If you take a 4-inch diameter cylinder, and if you just support a platform on that, you could put 1,000 grown men on that platform, and they would be supported by this little 4-inch diameter cylinder.
Under laboratory conditions, each sample is tested until it fails, so that in the real world, 20,000 tons of this, sitting at the heart of One World Trade Center, will be virtually indestructible. Ever since 9/11 and the decision to rebuild, that has been the ultimate goal. When the Twin Towers were built in the late 60s, steel was the key material. Most of their weight hung from dense vertical columns. That was how New York made its skyscrapers.
New York City, this is really a steel town for office building. Many buildings are built in a steel frame and steel columns, and then they're clad, wherever the core is or any enclosing elements, with drywall. And drywall is a very thin, readily buildable material.
But then the towers came down, and the rules changed. The concrete core of the new tower, 3 feet thick in places, is much harder to build, but it ought to withstand any impact.
We wanted that security of that concrete in the center core, in the spine of the building, to act as a protective measure for life safety.
It's not just about holding the building up. A whole series of life support systems, power supply, water supply, elevators, emergency stairwells, will all stay intact, protected by what is essentially the world's tallest bunker. That's why the strength of the concrete matters.
There was a time when we had to chip some concrete out, okay? And we found that there was a load or two of concrete that went in that wasn't good. It was taken out. We had to stop operations and take the concrete out, and we did. And but it brought the message home to everybody. We mean what we say. We will not accept anything but what's being specified. So get with it.
40 minutes after leaving, the trucks arrive on site. Pumping can begin. But time is running out, and the concrete still has a long way to travel. It must all move up a single pipe, 6 inches wide.
The line from the street all the way up to the core where we're at now, which is about 1,280 feet above the street. Right now we've got about 10 yards of concrete in the line before we actually even start pumping into the walls.
That's 20 tons of concrete in a vertical lift. It demands the most powerful concrete pumps on the planet, and it means an agonizing weight on the 102nd floor.
The concrete's not getting up here quick enough. We start to encounter problems in the line, especially at these elevations.
The danger is that the mix starts to cure in the pipe, and they find themselves left with a near solid column of concrete over 1,000 feet long.
We've got to make some serious decisions on whether we're going to blow the line back into the truck and start over again, or try to keep working and trying to keep pushing the line.
At last, just as they approach that 90-minute crunch point, the concrete starts to flow, and the walls of the core, 3 feet thick, can continue to rise.
All right, man. All right.
In 1 month, Brian's work will be finished.
All right.
He's given 5 years to this project.
At times it kind of wears off and you start to think of it as just another job, and then at times you kind of step back and realize actually what you're part of. This is a piece of history we're building here, and I'm very proud to be on it.
When architect David Childs and his team took on One World Trade Center, they knew that sense of history would define everything they did.
Yes, we had to be the best working office building. This is a commercial structure. But at the same time, we also know that we needed to be part of the memorial because, in fact, we are that vertical shaft that actually identifies where the site is from around the city. This iconic building fills that void in the sky that people really felt was missing.
What brought the two strands together was once again safety. The most fitting memorial would be a working building which used, down to the smallest detail, all the lessons learned from 9/11. They set out to do nothing less than rewrite the building code, the already strict set of rules that govern all construction in New York.
We took all the old rules and put them aside. Obviously, as a result of the tragedy after 9/11, we wanted to rethink a lot of things. Let me give you some examples. Firefighters would be rushing upstairs with their packs and hoses on their back to try to put out a fire as tenants were coming down the building. This was a clash. We figured out how wide stairs should be so that they could move in both directions.
Filters are being fitted which will purify the air in the stairwells, protecting against even a biological or chemical attack.
And there's a myriad of these kinds of things. Pressurize the stair to keep smoke from coming in the stair when somebody opened the door. We put a simple thing like a luminous tape that you might see like in airplanes inside the stairs so that if the lights were out, people could find their way down. And on and on and on.
The teams building the tower have tried to plan for all eventualities. But they can't know what's over the horizon. This city is about to face its sternest test since 9/11, and a force more powerful than any explosive. Over the 6 years since Steve Plate became construction director of the World Trade Center project, he's had to get used to being in the public eye.
So I call it Gump Wall. When you look at these pictures, usually the comment made is, who's the bald guy next to all these famous people? And that's me. So I call myself Forrest Gump. You remember the movie? Back to my right here is the Queen of England, Prince Harry.
He's had to learn never to be surprised at the challenges that the job produces. From day one, there have been obstacles that no one could have foreseen.
Got a contractor, started excavating, started trying to get momentum going with a project. It's like, where do you begin? We hit a ship, 17th century ship. We took that ship, we shrink wrapped it, shipped it down to a great museum. Then one day we're pouring concrete, and in Tower 1, there was an earthquake.
The 5.9 magnitude earthquake caused panic across some parts of Manhattan, sending workers out into the streets.
I haven't seen an earthquake, I don't think, since I was a kid. Okay, now we've hit everything again. Well, after about third or fourth time you get the theme, I stopped saying that. What you're beginning to hear is the story of resiliency.
But the biggest test was still to come. On October 23, 2012, a storm moving north through the Atlantic was formally reclassified as a Category 1 hurricane.
This is a serious and big storm. You need to take this very seriously.
It was given a name, Hurricane Sandy.
I remember gearing up for it, doing everything with my staff to protect the site. You know, it's the analogy of having your house under construction without a roof for protection when all this water poured in.
Hurricane Sandy made landfall on the East Coast on October 29th. It claimed 286 lives. It cost New York State alone almost $42 billion. Whole districts of the city lost power. The subways were flooded. The National Guard was deployed. And the site of the new World Trade Center, right next to the Hudson River, was hit hard.
125 million gallons of water poured into the site. I can't even describe how much that is. It's a 16-acre site with at least 10 to 40 feet of water throughout.
It was too dangerous for news crews to get down there, but subway security cameras captured the devastation. Plate surveyed the damage with Governor of New York Andrew Cuomo.
I remember Governor Cuomo saying, how many days you're going to take? And I said, I'm going to try my best to do 2 to 4 weeks. I put my staff on it. I said, don't do anything that's going to hurt anybody, and do everything as honestly as you can, but go. In 2 days, they had the entire site empty of water.
Though all of Lower Manhattan was blacked out and the tower's massive power plants had been completely submerged, work restarted within the week. It's 6 weeks since Sandy hit. All concrete pouring has been completed. The glass crews have made it to the 90th floor. And it is a landmark day in the construction of One World Trade Center. Having been cast 300 miles away in Quebec, the first pieces of the building's spire are coming up the Hudson River. When all 18 pieces are stacked on top of each other, their tip will stand 408 feet above the building's roof and take its total height to 1,776 feet. A number chosen to echo the year of American independence.
Well, what you see here is basically the candle on top of the cake, the candle being the spire. And what we're following right now is 9 pieces of the 18 pieces of that spire that'll be being placed on the top of the building.
On site, General Superintendent Mike Pinelli makes final preparations to bring the spire pieces from the docks. They will travel by night, under escort, through the streets of Lower Manhattan.
This is ILD. All right. Bobby, we're good to go?
He's been responsible for all comings and goings over the last 5 years. Every yard of concrete, every inch of metal.
Johnny, come in, Johnny.
But this is still going to be a complex, stressful job. It's not just the symbolic significance. Some of the pieces are close to 30 feet tall. They weigh upwards of 40 tons.
We have to coordinate to move street lights, tree limbs. We've been working at this for months with Port Authority Police, the New York City Police Department, so there is a tremendous effort that we've put into this today and that we're gonna have to put in to get these pieces here.
It's just a couple of miles from the dock to the site, but Pinelli's team have a long evening ahead of them.
To do this task, we've got a Chesapeake 1000, which is a barge crane, 500 ton. It's gonna pick the pieces off the barge. We will place them on specialized trailers on the West Side Highway. The project I related to running a marathon.
As the spire's base starts to move, Lower Manhattan comes out to watch. In addition to the formal police escort, Dozens of tower workers make up a guard of honor.
It's something you don't see in the city of New York every day. Parade of vehicles, Port Authority police cars with their sirens on, a specialized custom trailer with light stands. At 11 o'clock at night, the rest of Manhattan on the weekend and evening is out having dinner and drinks and with their girlfriends and wives and having fun, and here we come marching up the street like the Macy's Day Parade.
People coming out the doors to see what was going on. They were very excited. They were quickly realizing what was going on. It almost became a New York happening.
By the time the pieces reach the site, it's 1 a.m. Now there's just the little matter of lifting it 1,400 feet into the air. This will be the highest vertical crane lift ever attempted on a building in America.
To us, the Spire is like another whole project here. It's very challenging. The top of the house at 104 right now is like it's got its own weather climate. There's days that we're in the clouds. There's days that it's cloudy down on the ground and the sun's up top. Obviously much colder up there. There's days that it's raining down here and it's not raining up there. I've checked 62 forecasts so far today, and everyone looks like it's going to be okay.
Kevin Murphy was one of those who walked with the Spire's base last night. Today, he'll see it to its final destination.
I'm a third-generation iron worker. A lot of my family are iron workers, besides my father and grandfather, my cousins, my uncles, my brother. It's kind of born into it, I feel like.
Like many of his colleagues, he saw the aftermath of 9/11 firsthand, helping to clear the wreckage of Ground Zero.
The cleanup here was tough. So to be part of this is just, it's hard to put in words.
But the completed Spire will look vastly different from the original plans. It had been intended to clad it in keeping with the rest of the building. But then wind tunnel testing showed the design had a serious flaw. At certain low wind speeds, the kind of wind New York sees regularly, the Spire would start to vibrate.
The effects resulted in significant motions of the Spire, at the tip of the Spire. They could be in the order of several feet, and that could occur on a monthly basis.
As the wind picked up, the effect would diminish, but then return much, much stronger.
The effects of that long term would be fatigue in the material, and then ultimately is failure of the material as it's fatigued.
The only way to avert disaster was to produce the Spire without its cladding. Now just the network of beams and cables, the wind can pass through it, and the problem disappears. Murphy's iron workers have built a vast but temporary steel frame. Each piece is to be lowered in and bolted down before the next comes.
For us, the biggest challenge of mine working is staying out of the way and not getting hurt, getting pinched, getting crushed.
The difficult and controversial bit is now what to call this steel structure. If it's called a spire, it's part of the building. But without the glass, if it's just an antenna, according to the international body, the Council of Tall Buildings, it can't be counted as part of the total height. It's been said in the press that the tower won't really be 1,776 feet tall. Does that matter to the guys on the ground?
The eyes of the world are watching us here every day. Sometimes it's good, sometimes it's just not so good. You know, this job is going to define the skyline of New York City.
But now the process has to be repeated with the other 17 pieces. They have 21 weeks to get the last one, the building's pinnacle, into place. Given the weights involved and the sheer height they're operating at, time is going to be tight. The teams work on through another tough New York winter. It is the 6th winter on this job. February 6th, 2013. Today, life might get a little easier. It's not the kind of thing that the press makes a big deal of, but when your daily commute involves a 1,700-foot climb, it matters. This morning, the building's internal elevators come online. Up until now, everything going up has traveled in these external hoists. In any other situation, this much steel would seem like a massive engineering feat in its own right. Here, though, the hoists were just a temporary solution. They'll soon be dismantled.
45.
And the long, cold journey to the top, which could take as much as 40 minutes out of a worker's day, is about to become a thing of the past.
Our elevators run at a much higher speed than the outside hoists do. It allows the laborers and other trades to get to the floors faster. They'll be able to travel from lobby level to top of the building in under 1 minute.
Coming down.
What's good for the construction crews will also be good for the office workers who will soon take over this building.
The bottom line is for efficiency of moving people into the building and up to where they have to go to work. Obviously, time is money, and the faster you can get people to their place of work, the better off for everyone.
Each car is a record breaker and a source of pride to the men who operate it.
This particular bank is 1,800 foot per minute, which is among some of the fastest not only in the country but in the world. The only faster cars that I've been involved in, aside from these 1,800 foot per minute cars, are the 2,000 foot per minute cars that are the next bank over.
Progress, right? That's what it is. How's everything today, John? Up and down, baby. That's all I got for you.
Already at the top are Frank Coletta and his crew. The job of fitting glass has become a daily battle.
Yell down to Brian, the engineer, or send Al over, wherever you got. The weather is really the biggest challenge when you get up this high. It's completely different from 40 floors. It's a whole nother world up here. It's the same panel on 2 as it is on 102. We set it the same way. It's just really the wind and the weather that really makes things tough here.
Coming up a quarter on this side.
In more than 1,000 days on this project, they have fitted more than 13,000 panels. Now for them, the finish line's in sight.
Can I come up 3/16?
Coming up to the top and knowing we're going to put the last curtain wall units on the outside, it's going to be great that we're going to be getting out of here, but in the end, it's going to be a little bittersweet that, you know, this has been a really great job for me and the guys, and we really would like to stick around longer, but unfortunately, when we're done, we got to move on to the next one.
Down on the ground, though, one worker who's new to the site. Lighting engineer Benjamin Tevelo. Construction sites aren't his usual environment.
I work for everything from the New York State Theater and the Metropolitan Opera down to small high schools in Queens. This is a very big one. This is right up there.
Benjamin's job is to test and install the lighting system, which will top One World Trade Center and turn it into a nighttime landmark. At its heart is a revolving beacon light, similar to what you'd find on an old-fashioned lighthouse. One of the most powerful of its type, it uses 288 LEDs to send out a horizontal beam of light that will be visible 50 miles away. On top of that, hundreds more LEDs will adorn the outside of the spire. They'll be computer-controlled, changing color and pattern at the touch of a button.
So my job is to take all of those different things and put them together into a single, very pretty graphical user interface where somebody can click on a spire and then click red, and then poof, it goes red. So it's a lot of responsibility to be the one to make sure that it turns on when it's supposed to.
The problem is, it isn't all going as it's supposed to.
A couple minutes ago, I was running around in a bit of a hurry. We went to turn on the motor and it didn't turn on. That's the big fear, is you say, okay, we're turning it on, and then nothing happens.
Just to add a little more stress, an audience of dignitaries has come to watch.
Today we have a whole bunch of people who get to say, yes, it's good enough on site. They're the building managers, they're here, the Port Authority, heads of all the companies involved.
There are also the men who came up with the whole lighting scheme. International lighting consultants Claude Engel III and Claude Engel IV. During a career that spans 6 decades, Claude Sr. has lit buildings and monuments all over the world. This one trumps them all.
Clearly you had to do something at night. This building had to have a presence at night. But we began to realize that if it had anything Vegas-like to it, lots of colors, that this would be totally inappropriate for the solemnity.
What inspired the Engels was the fact that there had once been a plan, never realized, to put a revolving beacon on the original World Trade Center.
We were reminded of the fact that in the case of the Twin Towers, the architectural team had very much wanted to have it be a beacon. So this, I think, is achieving finally what the architect of the original building looked for. So there's a continuum that I think means a lot.
After a few awkward moments, Benjamin manages to resolve his problem, and all of the onlookers are satisfied.
How do you like that? I'll be able to see it from my house.
So I had to dig into some of the code that I've been writing for motor control. It turned out to be a small thing. I just found a little loop in the code, fixed that, and then we got it turned on easily. It's all in tiny little files that are scattered about.
Eventually, the whole system will be remotely controlled and monitored.
Those fixtures in which those LEDs are embedded they each have circuitry built into them to monitor every individual LED. So when one burns out, it throws a little flag that pops up on the control interface. It says, there's an LED out. Somebody should go look at that. And chances are, with that many LEDs, if one burns out, nobody's going to climb up there to fix it. They're going to wait until 10 or 12 are burned out.
By that stage, changing a blown bulb will be an epic adventure. An elevator ride up 104 floors, followed by a 408-foot ladder climb. It pays to get it right now. Of course, there are people who don't think twice about working at height. Fearless ironworkers moving high above the traffic have long been part of New York folklore. And they've been part of this build since the beginning. For all the technical sophistication and cutting-edge design that's gone into One World Trade Center, this building wouldn't have happened without them. In 100 years of skyscraper construction, one thing hasn't changed. You still need men who are prepared to step out into space and put the steel together. There are 50,000 tons of structural steel surrounding the tower's concrete core. And from the ground up, all of it has been manhandled into position by 4 men.
There's been 2 cranes the entire time, so it's been 4 connectors the whole way. For the entire building, yeah, 4. And we actually connect the pieces together, put 1 bolt each end, and we move on, and then the bolter-ups come up behind us, put the rest of the bolts in, and plumber-ups come, the welders, so on and so forth. So we initially put the building up. We're the first guys to touch the steel.
Today is the 18th of April. With 3 weeks left until the spire is completed, Mike O'Reilly and his opposite number, Timothy Conboy, are completing the tower's communication rings, which will crown the roof and carry millions of dollars of telecoms equipment. Getting here in one piece has taken almost 7 years of hard work and constant vigilance.
Just staying safe. I mean, going home every night with your toes and your fingers, you know? It's a real dangerous job, and you got to be alert all day long. You know, falls, you get hit with pieces, you know, pieces are slamming around, you could easily lose a finger. I mean, you could fall off the iron. There's a lot of dangers. But in ironwork, and that goes with the business, for whatever building you're on.
Mike is another one with iron working in his blood. But his story is that he was never meant to do this job.
My father was an iron worker, as well as his brother. My dad got hurt on the job on 7 World Trade Center. So as a little kid, I wasn't allowed to become an iron worker. And it wasn't until these buildings fell down that I reapproached him, asked him again if I could become an iron worker and follow in his footsteps. And so I have. It's awesome. It's an awesome job to have. It's the only job I would want in the construction business. We like it. We like it. We're away from everybody. You know, we're off the street. Nobody can bother us up there. No one's allowed up there where we work. So we're away from everything, and it's quiet, and we just get our job done and move along.
This is Mike's definition of quiet. The communication rings designed to slot snugly into place. But getting it to fit requires a little delicate surgery.
Well, it just involves stacking pieces together. I mean, it's not that difficult of a job. It's just heavy picks.
The next piece is already on the way up, and the job will soon be done.
Nothing's there before, and when you're done with your job, at the end of the day, there's a building in the sky. I changed the skyline, and it's an awesome feeling.
The final piece of the spire swings into place on a clear spring day. It's carrying the stars and stripes and captured in pictures that are beamed around the world. Mike O'Reilly and the other iron workers do their job here one last time. Nothing in New York has ever stood this tall. There is still work to do, another year at least, before all 2.5 million square feet of the interior is ready. But this is the high point of a journey that began almost 12 years ago in the rubble of the Twin Towers. They've come from ground zero to 1,776 feet.
We had to do something that really had a defining moment in history. You can sit there and say it's the tallest building, the most complicated steel, but this one transcends. It's about friends working with each other, about people setting aside their personal needs to do what's right. I walk around the site every day. People grab me and say, you know, this is really a special place. This is a construction worker, 7:30 in the morning, wants to express his need to be here and his passion about this job.
The Council for Tall Buildings has officially confirmed One World Trade Center's status as the tallest in the Western Hemisphere. Those who built it believe that it is the safest and strongest on Earth. In a city that constantly reinvents itself, where the typical life of a building is little more than 50 years, this tower is unique. Because of the way it was built, and because of what it means, One World Trade Center is here to stay.